Good evening, sir. My name is Jagannath Kumar. I am from CSM Department of B section from the SRIT College. Today I am presenting a CA2 assignment of video from the subject of probability and statistics. So today my topic name is derive the mean and variance of the normal distribution. So here we can see the topic name with the derive the mean and variance of the normal distribution. So at the first slide we have to introduce to the normal distribution. So the normal distribution is a continuous probability distribution that is symmetric about its mean. It is characterized by its bell-shaped curve, which is defined by two parameters. First one is mean and the standard deviation. The first mean is denoted as the mu and the standard deviation is denoted as the sigma. And the understanding the mean and variance is essential for statistical analysis as they describe the center and spread of the distribution. Here we can see the continuous probability distribution. There are the four types. First one is uniform distribution, and second one is exponential distribution, and third one is triangular distribution, and the last one is normal distribution. And next, definition of mean. So the mean of a random variable is the expected value representing the central location of the distribution. Next, in the context of the normal distribution, the mean is denoted by mu. We have already told that in the old slide. Here we can see that the parameters of the two are the first one is mu and the second one is sigma. So like that, it serves as the point of symmetry where the curve balances and is the highest point of the bell curve. So this is the slide of the explanation of the mathematical expression for mean. So we have learned the definition of mean in the old slide. So in this slide we can learn the mathematical expression for the mean. So the mean of the normal distribution can be derived from its probability density function. It is also called as the PDF. So the PDF is given by f of x equals to 1 by sigma by root of 2 pi, that equals to e power into minus x minus mu whole square by 2 sigma whole square. So here we can see mu is called as the mean and the sigma is called as the standard deviation. So this is a small example of the expression, like mathematical expression for mean. Next, deriving the mean. The integral used to derive the mean is represented as e into x, that implies mod of x, f of x dx from minus infinity to plus infinity. So after substituting the PDF and simplifying the integral, we find the mean is equals to mu. It is the deriving of the mean. And the second step, the definition of the variance. Variance measures the spread or dispersion of the distribution around the mean. For the normal distribution, variance is denoted by sigma square. It quantifies how much the values of the random variable differ from the mean on average. And this slide has been defined as the mathematical expression for variance. So in our past slide, we have learned about the mathematical expression for mean. On this slide, we can learn about mathematical expression for variance. Here, the variance can be expressed as varchar into x, that equals to e into x minus mu whole square. So this requires evaluating the expected value of the square deviation from the mean. The formula captures the average of the square differences between each value and the mean. So this is like a small example of the mathematical expression of our variance. Here the condition variance of x is given by, it is denoted by varchar of x into x by y, that equals to e into x minus e into x by y whole square by y. So here show that the equation is classified as varchar into x equals to e into varchar into x by y plus varchar into e into x by y. So here deriving the variance. To derive the variance, we need to compute e into x minus mu whole square, which involves integrating the squared term multiplied by the PDF. The integral is computed as integral x minus mu whole square, that implies f of x dx from minus infinity to plus infinity. So here also we can see that f of x, like the variance of the some topic or some example. Here we can learn about the dx form from that, and it means the value of the f of x or d of x is from minus infinity to plus infinity. And the summary of mean and variance. So here we have learnt about the separate definitions and mathematical expressions of the mean and variance. So here the both continuous of the summary of mean and variance is classified as the mean of the normal distribution is mu, so which indicates the center of the distribution. The variance of sigma square representing the spread of the distribution around the mean, and that together these parameters fully characterize the normal distribution. Here we can see the formula. So here we can see the formula of the summary of mean and variance. That implies, first of all, the mean mu equals to 0 into 1 minus p plus p into 1. And the next one is variance. That implies as sigma square equals to p into 1 minus p. So, and next standard deviation, sigma equals to root of p into 1 minus p, that equals to root of sigma square. So here in these three steps, mean, variance and standard deviation, p stands for the probability of success, and the another one, q or 1 minus p, equals to probability of failure. So here p stands for the probability of success, and 1 minus p, that is also called as q, so it is also stand for the probability of failures. And the next one is importance in statistics. The mean and the variance of the normal distribution play a crucial role in statistical inference. They are used in hypothesis testing, confidence intervals, and regression analysis. A solid understanding of these concepts allows for more effective data interpretation and decision making. So it is a small example of like graph for the statistics. Here we can see the on the x-axis there are 0 to minus 5 as the negative integers, and 0 to plus 5, that's as the positive integer. And also in the y-axis we can see here about pointwise 0, 0.1, 0, 0.2, 0, 0.3, 0.4, 0.5, 0.6, 0.7, and the 0.8. So here we can see the green line can be represented as the positive surface, like positive data values, and the red line is stands for the negative values. And this is the conclusion. So this is the conclusion of my ppt for this topic. The normal distribution is fundamental in statistics, with the mean and variance providing vital insights. Mastery of their derivation enhances analytical skills and statistical reasoning. The next, understanding these concepts is essential for anyone working in data driven fields. Feel free to customize or expand upon any of the slides as needed. So this is the conclusion of my topic. So thank you, sir. Thank you for this opportunity.